weigh the same. Okay, 8 oxygen atoms and 3 carbon atoms are going to actually weigh the same if that's the case. So again, this is assuming that the atoms of carbon and oxygen have the same mass, because we know that they combine together differently. They combine together in 4 oxygen atoms to 3 carbon atoms, or they combine in 8 oxygen atoms to 3 carbon atoms, and that's where these two come from. Now that's hypothesis number 1. Hypothesis number 2 says oxygen atoms are heavier than carbon atoms by the same ratio in compound A. Okay, so again, we're going to refer only just to compound A. The oxygen are heavier than the carbon by that same ratio. So if that's what they're saying, so if the oxygen atoms are 1.33 times heavier than each carbon atom, then what that means is we actually have a 1-to-1 ratio. We actually have 1 carbon and 1 oxygen. Again, because if your mass of oxygen is 1.3 times bigger than your mass of carbon, then that means you have 1 oxygen to 1 carbon. It's a 1-to-1 ratio. And if we're going to use this same ratio, that oxygen is 1.3 times more than carbon, what if the oxygen is 2.6 times more than carbon? Well, if that's the case, then that means that we have to have 2 oxygens. So if the oxygen atoms are 1.3 times heavier than carbon atoms, again, as here it says, we're going to use the same ratio as in A. Okay, so the ratio in A is 1.3 oxygen to carbon. And so here we're still using that same ratio again. So if that's the case, then what that means is that we actually have 2 oxygen atoms. So it turns out that hypothesis is the one that is actually true and correct, is that the atoms of oxygen are actually heavier than the atoms of carbon. And we can find that by being a 1.3 to 1 ratio. Now, if you want to compare that on the periodic table, let's take a look on the periodic table. We see oxygen is 16, carbon is 12. If we took 12 and we multiplied that by 1.33, sure enough, we get right close to 16. So that, from what we can see, that hypothesis 2 is correct. I hope that helps.